Hi there. Today we're talking about multiplication and division of polynomials. We're going to see how polynomials can be multiplied or divided. We already know what polynomials are and we can add and subtract them. So let's go straight to that. Multiplication and division of polynomials. Multiplication and division of polynomials. There we go. Let's take an example. Example 1. Given that P1 of x is equal to 2x squared plus 5x plus 6 and P2 of x is equal to 3x squared minus 2x plus 1. Find P1, P2. That simply means find the product of P1 and P2. We go straight to the solution. P1 of x, P1, P2 equals P1 of x, which is 2x squared plus 5x plus 6 times P2 of x, which is 3x squared minus 2x plus 1. Now to multiply this, we simply multiply each of the terms in the first polynomial by the whole of the second polynomial. So we are multiplying 2x squared by the whole of this and 5x by the whole of this and then 6 by the whole of this. That's how to go. So that's going to be 2x squared times 3x squared minus 2x plus 1 plus 5x times 3x squared minus 2x plus 1 and then plus 6 times 3x squared minus 2x plus 1. Now we can open the brackets. That will be 6x raised to power 4 minus 4x cubed plus 2x squared plus 15x cubed minus 10x squared plus 5x plus 18x squared minus 12x plus 6. Let's check to be sure. That's 6x raised to power 4 minus 4x cubed plus 2x squared plus 15x cubed minus 10x squared plus 5x plus 18x squared minus 12x plus 6. Now we can add it. We can collect like terms. There's only one 6x raised to power 4. There's only one x raised to power 4 term, so that will be 6x raised to power 4. Now we combine the like terms. Minus 4x cubed minus 4x cubed plus 15x cubed is 11x cubed. That's plus 11x cubed. Now to the x squared term, plus 2x squared minus 10x squared is minus 8x squared plus 18x squared. That's plus 10x squared. Now let's go to the x terms. 5x minus 12x is minus 7x. And then to the only constant. And then to the only constant, which is 6. So we have plus 6. And that's the final answer. Now That's how multiplication is done simply. Now let's take an example 2, which is going to be on division. Example 2, given, find the quotient and remainder. Find the quotient and remainder. Find the quotient and remainder when P of x, which is equal to 6x cubed plus 4x squared minus x plus 5 is divided by 1, 3x squared plus 2x plus 1, 2, x cubed minus 3x plus 2, and 3, 6x squared plus x minus 2. Now let's see how that's done. That's very, very simple. The first one, the polynomial is, we are using the long division method. The polynomial is 6x cubed plus 4x squared minus x plus 5. And we are dividing it first by 3x squared plus 2x plus 1. So what we do here, first of all, is we divide the first term. By the way, what we are dividing is called a dividend. This is called a dividend. And what we are dividing it by is called a divisor. And whatever we get is called a quotient. So now this is how to do the division. We divide the first term of the dividend by the first term of the divisor. And that means we are doing 6x cubed divided by 3x squared. That's going to be 2x. So whenever you get an answer, you multiply the whole of the divisor, which is 3x squared plus 2x plus 1, by that answer you have got. So now we are multiplying 3x squared plus 2x plus 1 by 2x. When we do that, we write the answer under the dividend this way. 3x squared times 2x is 6x cubed plus 2x times 2x is 4x squared plus 1 times 2x is 2x. Now, when we get an answer that way, we subtract. 6x cubed minus 6x cubed is 0. 4x squared minus 4x squared is also 0. 4x squared minus 4x squared is 0. And then we are left with, this is minus x, that's minus x minus plus 2x, which is the same as minus x. Minus times plus is minus 2x, and that will be minus 3x. So the answer here is minus 3x. And then the answer there is minus 3x. And now we bring down the next term of the dividend, which is 5. And then we check again. Here, the degree of the first term here is less than that of this. So we can't divide further. Before you divide, what you are dividing must have the same degree, must be of the same degree as what you are dividing it by, or of a greater degree. So here, minus 3x has a degree that is less than that of 3x squared. So we can't divide further, and we just stop there. And the answer is, and the quotient is therefore 2x, which is a result, while the remainder, which is what's left there, is minus 3x plus 5. Now we go to Roman figure 2. When you multiply the quotient by the divisor and add the remainder to that product, you are going to get the dividend. So let's go to Roman figure 2. In the same vein, we are doing long division. 6x cubed plus 4x squared minus x plus 5 divided by 3x squared plus 2x plus 1. Now we go, no, that's not the divisor. Remember we got 2. The second divisor is supposed to be x cubed minus 3x plus 2. This time we are dividing it by x cubed minus 3x plus 2. Now we go the same way. 6x cubed divided by x cubed. That's 6. That's 6. When you get an answer, you multiply the whole of the divisor by that answer. So we are multiplying the divisor by that answer now. And then we have 6x cubed. X cubed times 6 is 6x cubed. Minus 3x times 6 is minus 18x. 2 times 6 is 12. That's supposed to be, yeah, that's what it is. Minus 3x times 6 is minus 18x. So there is no x squared term. So I'm just going to write 0x squared and then minus 18x so I don't get confused. You put an x squared term under the 4x squared before you write the result of the multiplication, which is minus 3x times 6. That's minus 18x and then 2 times 6, 12. That's just to avoid confusion. Now you subtract 6x cubed minus 6x cubed is 0. 4x squared minus 0x squared is 4x squared. Now minus x minus 18x is the same as minus x. Of course, minus times minus is plus 18x, which is 17x. So we have 17x, and now 5 minus 12 is minus 7. So let's see. The degree of 4x squared is less than that of x cubed. So we can't divide further. We just stop there. And that therefore means, quotient is equal to 6 and remainder equals 4x squared plus 17x minus 7. 4x squared plus 17x minus 7. Down to the last one. Roman figure 3. We're doing the same. That's the same method. Dividend, which is 6x raised to the power 3. 6x raised to the power 3 plus 4x squared minus x plus 5. This time we're dividing it by 6x squared plus x minus 2. 6x squared plus x minus 2. So we go the same way. 6x cubed divided by 6x squared. That's x. And now we multiply the whole of this by that x, which is going to be 6x squared times x, 6x cubed, x times x, x squared, and then minus 2 times x, minus 2x. Now we divide. Now we subtract 6x cubed. 6x cubed minus 6x cubed is 0. I'm subtracting. I should write the minus. 6x cubed minus 6x cubed is 0. 4x squared minus x squared is 3x squared. Now this is minus x. Now we're doing minus x minus 2x. And that's going to be minus x minus 2x, which is minus x. You do minus times minus plus 2x. And that's x. So the answer here is x. And then we bring down the next term, which is 5. So we move on. The degree of 3x squared is the same as that of 6x squared. So we can divide. Now we divide 3x squared by 6x squared, and that's going to give us half. Three x squared divided by 6x squared is 1/2. And now we multiply as usual the whole of the divisor by that result. And that becomes half 6x squared times half is 3x squared plus x times half is half x, and then minus 2 times half is minus 1. So we subtract again as usual. 3x squared minus 3x squared is 0. X minus half x is half x. And then 5 minus minus 1. Of course, that's 5 minus minus 1, which is same as 5 plus 1. And that's 6. Because that's 6. So that means, therefore, the quotient, is equal to x plus half, and the remainder is half x, or if you like, x over 2 plus 6. And that's it. Very, very, very simply. That's how to divide polynomials. Now let's go to something else. Zeros of a polynomial. Zeros of polynomials. Zeros of polynomials. Zeros of polynomials. Zeros of polynomials. This is also very, very simple. The zeros of a polynomial are just the values that make the polynomial true when substituted for the variable. For example, let's go to that. If I have a polynomial of p of x, for example, okay, find is just like, let's call that another example. Let's have an example under that. Let me call it our first example under this. We already had 2 examples. This is let me call this example 3. Our third example so far. Now, find. So they are the values of the variable which satisfy the equation when the polynomial is equated to 0. Let's see how that's done. Find the zeros of the polynomial Oh, let me do this before I go to an example. To find the zeros of the polynomial, say for example, to find the zeros of the polynomial p of x, put p of x equals 0 and solve the corresponding equation When you do that, you obtain the zeros of a polynomial. You can also call them the roots of a polynomial. Now let's take an example on that, which is our third example today. Find the zeros. Find the zeros of a polynomial p of x. P of x equals x squared minus 5x plus 6. For a polynomial p of x equals minus 5x plus 6. How do we do that? Now, let's go to the solution. P of x is given by x squared minus 5x plus 6. Let P of x be equal to 0. And that simply means x squared minus 5x plus 6 equals 0. And then we solve this equation. And when we do that, we're going to have x squared minus 3x minus 2x. When we try to solve that by factorization, that's what we have. And that means x into x minus 3 minus 2 into x minus 3 equals 0, which means x minus 2 times x minus 3 equals 0. And therefore, x equals, of course, you know how that's done. That simply means x minus 2 equals 0, or x minus 3 equals 0, which therefore means x equals 2 or x equals 3. And the zeros of the polynomial, therefore, the zeros of the polynomial the zeros of the polynomial p of x are 2 and 3. Those are the zeros of the polynomial. So that's it, very simply. That's how to find the zeros of a polynomial. Now quickly to the next concept, which is the remainder theorem. The remainder theorem. The remainder theorem. The remainder theorem. Now let's see. When a polynomial, this is what the theorem states or is about. If the polynomial f of x is divided by x minus a, is divided by x minus a, the remainder is the same as f of a. The remainder is the same as f of a. The remainder is the same as f of a. So let's take an example. Let's take an example, which is our fifth example, which is going to be our fifth example. Now, given that f of x is equal to 3x cubed minus 4x squared plus 2x plus 3. Find the remainder when f of x is divided by x minus 1. Is divided by x minus 1. Solution. Now, we already know what the remainder theorem is about. If you divide a polynomial f of x by x minus a, the remainder is going to be f of a. And that's the concept, that's the approach we are adopting here for this division. So, given f of x, which is equal to 3x cubed rather, minus 4x squared plus 2x plus 3. When it is divided by, when f of x is divided by x minus 3, when f of x is divided by x minus 1. The remainder is the remainder is f of 1. So what does that mean? Let's make r the remainder. Let r be the remainder. Let r be the remainder. And that means r is equal to f of 1. And f of 1 is what you obtain when you substitute 1 for x in f of x. That's 3 times 1 raised to power 3 minus 4 times 1 raised to power 2 plus 2 times 1 plus 3, which is equal to 3 minus 4 plus 2 plus 3. And that's going to be, and that's 4. 3 minus 4 is minus 1 plus 2 is 1 plus 3. That's 4. So f of 1 is the remainder when f of x is divided by x minus 1. Sorry. So 4 is the remainder, yes, which is the same as f of 1 when f of x is divided by x minus 1. Now, so a second example on that. Example 6. Find the remainder when f of x equals divided by. Find the remainder find the remainder when f of x, which is equal to 2x cubed plus 3x squared minus 4x plus 1 is divided by 2x plus 1. We go straight to the solution. F of x equals 2x cubed plus 3x squared minus 4x plus 1. Let r be the remainder. Let r be the remainder when f of x is divided by 2x plus 1. That means the remainder r is f of minus 1 over 2 by the remainder theorem. The remainder is going to be, when it's divided by 2x minus 1 and not 2x plus 1, 2x minus 1. When f of x divided by 2x minus 1. So the remainder will be f of 1 over 2. F of 1 over 2, which is equal to, and now you substitute 1 over 2 for x in f of x. That's 2 times 1 over 2 cubed plus 3 times 1 over 2 squared minus 4 times 1 over 2 plus 1. And that's equal to 2 times 1 over 8 plus 3 times 1 over 4 minus, of course, 2 plus 1, which is the same as 1 over 4 plus 3 over 4 minus 2 plus 1, and that's 0. Since the remainder is 0, that simply means 2x minus 1 is a factor. Of course, if you divide a factor by another factor and the remainder is 0, that means the other factor is, if you divide a by b and the remainder is 0, that means b is a factor of a. That's what it means. So therefore 2x minus 1 is a factor of f of x. 2x minus 1 is a factor of f of x. So that's going to be it. Very, very simply. I'm sure you understand everything. It's as simple as that. I will take more examples and more challenging questions in the next, more examples and more challenging questions in the next. I'm sure you got everything that was taught and you will be able to understand them when you go through them thoroughly on your own. Thank you very much and see you in the next. Bye.